Hey everyone, welcome back to the channel. In today's video, I am going to tell about race conditions. Whether you are a beginner or an experienced developer, understanding race condition is essential for writing reliable and efficient code. So let's get started. So imagine you are at a busy intersection where two cars approach from different directions. Both drivers see the traffic light is green and decide to go at the same time. Without clear rules, this could lead to an accident. Similarly, in a programming race condition, occurs when two or more threads or process accesses share the data and try to change it simultaneously. The outcome depends on the sequence or timing of their execution. In the previous video, I have explained about the bankers banking system, which a person has two debit cards and he has an amount of 25,000 or 20,000, and he and his friend simultaneously try to withdraw the money of 15,000. So he has only 20,000 but he tries to withdraw of 30,000. Here the race condition occurs. So what exactly is a race condition? A race condition happens when multiple threads or processors compete to access and modify shared data. If not properly managed, the final state of data can be vary on which thread finishes first. The race between them determines the outcome. So let us take of an example of, let me create a class as race. It has a counter. Let us take as count is equal to 0. So here we will write as public void increment. Let us write as count plus plus. So here now I am going to create two threads of race r is equal to new race. So thread t1 is equal to new thread. As we all know, we can apply lambda expressions for this. As we all know that these are functional interface, a type of. So here we are going to use as for int I equal to 0 and I is less than 1000 I plus plus. We can write this as r dot increment. Here I am going to create the same thing for thread 2. So now I am going to start both the threads, t1 dot start and t2 dot start. Now I am going to use the join t1 dot join t2 dot join, and we can write here the exception as e dot print stack trace. So let us know what will be the final output, like r dot counter. We will call this counter. So you expect what will be the output? we are giving 100 and 100. No, let us take the bigger value, 1000 and 1000. So what will be the output? See, we must get 2000, right? But why we are getting 1851? Because I will explain you with an example. So the both A and both the thread 1 and thread 2 are trying to do the same thing simultaneously. So the scheduler or the compiler thinks takes only the one, so it doesn't take the other one. So we are getting the unexpected values every time we run. As you know, see, we are getting 1655, 1659, like those. So let's break this down. The increment method looks simple, just counter plus plus. But under the hood, this operation involves three steps. Read the current value of counter, increment it by 1. Write the new value to the counter. When two threads perform these steps simultaneously, they can interface with each other. For instance, both threads might read the same initial value before either writes back incremented values, leading to missed increment. So as I have told before, like this it will occur. So as a result, the final counter value ends up being less than expected. This unpredictable behavior is essence of race condition. To better understand race condition, let's consider a couple of real world analogies. First, the traffic intersection we mentioned earlier. Without traffic lights or stop signs, cars from different directions racing through the intersection can cause chaos. And the second thing is, imagine a kitchen where multiple chefs are working on the same dish without coordinating their actions. One chef might add salt while another is adding sugar, leading to ruined meal. In both cases, lack of proper synchronization leads to conflicts and unintended outcomes. So, what are the consequences of race conditions in the software? Data corruption, unexpected behavior, security vulnerabilities, system crashes. These issues highlight why it's crucial to address race condition in your code. So preventing race condition is so much important. So now that we understood what race condition are and their consequences, let's discuss how to prevent them. Synchronization. Use synchronization mechanisms like synchronized block or methods in Java to ensure only one thread can access at a critical section time. So as you can see now, if I change this to synchronized, is giving me an exception. Let me quick fix. As I must write as public synchronized. As you can see now also it is giving an error, as I have to write I forgot to write as an. So now if I try to run this code, as you can see we are getting 2000. So again if I run this code, see I am getting 2000. So this tells us, if I go to this, if I once erase, so this tells there is A and there is B, or we can take as T2 and this is T1. T2. So the both are trying to run simultaneously. So it could leave the important points or they can start at the same value. So we are using a name called synchronized. So this tells to the compiler allow only one method at a time. So this tells it will allow only one at a time, so it will does not cause any race conditions. So as you can see in the code, every time after using this method synchronized keyword, we are getting the output of 2000. So that's all for today guys. Thank you for watching this video. Like, share and subscribe my channel. Thank you.